Was it 2015 or 16? 15. We finished the free response this morning. We finished them. I'm going to do the 2016 tomorrow. Okay?
Wait,
Just cranking.
I thought Thursday was the...
I got to switch it. Friday I'm doing college algebra at 7 a.m. Okay? Here we go. Calculus essentials. Let's fly through this first part. All right, this is going to be good review for everybody. All right, talk to me. Here we go. What's the derivative of a constant? Zero. I didn't know that until they told me this morning that they're leaving early for golf or something. They're leaving at like 7, Aubrey was saying. Aubrey and them and the girls. All right, derivative of x. What's the derivative of x? 1. What's the derivative of x to the n?
N times x to the n minus 1.
There you go. Simple power rule. What's the derivative of a constant times a function? Constant times the derivative of the function. It's not a big deal. You just multiply by the constant. You can only do that when it's multiplied by constant. How do you do this derivative of a sum or difference?
Derivative of the...
Each term. Just do the derivative of each term. Adding and subtracting, you don't have to worry about anything special. Just do the derivative term by term. Now, when you get to product rule, though, it does matter. You got to go the derivative of the... Now, if you want to just write f prime, if you don't want to write f prime of x, I'm not going to write the of x just because I want to shortcut it, and you're allowed to do this on the quiz. So f prime times g plus... I go f times g prime, but does the order matter? You can put g prime times f, and I'm going to totally count it. Okay? All right, quotient rule. Ready? Derivative of the top times the bottom minus the derivative of the bottom times the top. If you want to put the top first times the derivative of the bottom, that's fine too. That doesn't matter. But as long as when you're doing quotient rule, you do the derivative of the top first times the bottom and then minus. Over the bottom what? There you go. All right, chain rule. Derivative of the outside evaluated at the inside and then times the derivative of the inside. Could there be more links to the chain? Yeah, this is only 2 links, but there could be more. I think I've done it before where there's a u on the inside. If there's just an x, do you have to put the times 1? This is the exact test. The exact test. All right, now I put u's. What's the derivative? Now we need to memorize these because when I do the integral rules, it'll make more sense. Watch. If you know your derivative rules, you should know your integral rules. What's the derivative of sine? Cosine u times u prime. Don't forget the times u prime or it's half off. Actually, I'm counting it all wrong. Because it's just wrong. Because you just got to know it. Derivative of cosine. There is no halfway anymore. No partial credit on this. Got to lock in. Derivative of tangent. You guys say it. Derivative of tangent. Secant squared u times what? U prime. Derivative of cosecant. Negative cosecant u, cotangent u times u prime. Derivative of secant. Yes. Secant u, tangent u. I didn't call on you. Cotangent u. Very good. Negative cosecant squared u times what? U prime. Natural log.
1 over u times u prime.
Could you put u prime on top if you want? How many of you like putting the u prime on top? Totally fine. Okay? Derivative of e to the u. All right, now look, I just did 15 and 16. Don't miss 17 and 18. There's only one extra piece. All right, the natural log of a is the extra piece. So it's 1 over u times natural log of a times u prime. Now, if you did you're not usually asked to do the integral of the log, but if you did the integral of the log would be in reverse. So instead of dividing by natural log of a, you would
Multiply.
Yep. And on this one, it's going to be multiplied by natural log of a. So when you do the integral, you'll divide by natural log of a. So you always got to do the opposite. So on the log, you divide. So it's 1 over u times natural log of a on bottom. So if you did the integral, you'd have to have times natural log of a on top. And then on this one, it's just a to the u times what? Times ln a times u prime. But if you did an integral, you wouldn't multiply by ln(a), you would divide by ln(a). That's the only difference on the integral. By the way, they do not get complicated at all on the log base a and the a to the u. It'll be a multiple choice, and it'll be really simple. If you pretty much just know the rule, you'll get it right. Okay? You just got to get it memorized. You got to get it memorized. To get it memorized, you're going to get a lot of the multiple choice questions right. This right here has been a big key for kids, is making sure they get this memorized. I want it memorized by Monday. I want it done. I want the last 2 weeks to not worry about trying to memorize this crap. Get it done. All right. Arc sine. What's the derivative of arc sine? 1 minus u squared times u prime. Now, what's the only difference on arc cosine? Negative. Remember, the c's are always negative. Now, arc tangent. They are going to make you do an integral of arc tangent. It's the only one they make you do the integral of. Okay? And if you have the derivative rule memorized, you'll have the integral memorized in reverse. Okay? It's 1 over what?
1 plus u squared.
Times what? And in a minute, when you do the integral rule, it'll be obvious. You'll look at it and be like, oh, that's set up as the derivative of arc tangent, so the integral would be arc tangent. All right, what's the derivative of an inverse? 1 over the derivative of the original evaluated at the what? Say it with me. 1 over the derivative of the original evaluated at the, if you were here in the morning session last week, we did one of these. It was the last multiple choice question on the non-calculator on the 2016. All right, number 23. It's u over the absolute value of u times what? U prime. You don't really use it on the AP exam. Maybe once. You're probably not going to end up using it. Because usually what I do is I just set up absolute values piecewise. So here's what I would do. Personally, here's what I would do. If I ran into absolute values, I'd set it up piecewise. You don't have to put this on the quiz. But the piecewise would just be u and negative u. It's u for u greater than or equal to 0, and then it's negative u for u less than 0, and then I just do the derivative of each piece of the piecewise function. That's typically what I do. I just set up a piecewise function, and then I do the derivative of each piece. It's easier because I hardly ever remember this dumb rule, and I hardly ever use it. Now, you notice what I didn't put on here this time? Derivative of arc, secant, arc, cosecant, arc, tangent, because you're not going to see them on the AP exam. All right, definition of a derivative. Do you want them for extra credit? If you want them for extra credit, I'll put them on there for extra credit. Okay? Okay. I don't know what they are. They're arc, secant, arc, tangent, and arc.
Oh, we're talking about that. Oh.
Can you give them to me real quick? You have them. I'll write them up here for extra credit. So extra credit, EC, derivative of arc, secant. But you're probably, I've hardly ever seen them on the AP exam, and the only one I ever see is arc, secant, and I don't really see it. So arc secant has to be negative. Sorry, arc secant's positive. It's 1 over the absolute value of u, and it's the square root of u squared minus 1 times u prime. And then the only difference is arc cosecant is what? Negative. That's it. That's the only difference. So it's negative is all. Absolute value of u times the square root of u squared minus 1. And this really is more for if you decide to take further calc, you'll need them. And even in further calc, you don't use them that much. And then the derivative of arc cotangent, it's almost exact same thing as arc what? Tangent, except for it's what?
Negative.
It's negative. That's the only difference. It's arc tangent, but negative. That's it. So extra credit if you want those. Got them? They're on the old one. You good?
Yeah, just looking for my old one.
Yep. All right, definition of a derivative. There's 3 definitions you're required to know on the multiple choice. The first one is f prime of x. It's your standard definition for a derivative. It was the limit as h approaches 0 of what? F of x plus h minus what? F of x over what? H. And then your alternate form of a derivative was limit. It was f prime of c or f prime of a. I'll do a. I don't remember what I did. It's the limit as x approaches a of f of x minus f of a over x minus a. This one right here, I'm going to tell you right now, you're going to use these two on the multiple choice. You might use the third one on the multiple choice. And if it is, it'll be exactly how I have it. It won't be hard. It's the symmetric derivative. And it's the limit as h approaches 0 of f of x plus h minus f of x minus h over 2h. And it will literally be that way. And all they're going to ask is this a way to calculate a derivative? And you're going to be like, yeah, of course it is. Tell me when you got that copied and I can move on. Just seeing all this again is good because it helps, kind of helps you see it all. All right, integral rules in reverse. All right, these are the new part. It's a new section. Okay, it's your derivative rules in reverse. All right, the derivative of constant was 0, so what's the integral of 0?
Constant.
It's just a constant. All right, what's the integral of a dx, though? Not the integral of 0, but the integral of a constant.
Oh, we need the plus twos on all of them?
Yep.
Well, why is it A and not C?
Because I don't want to confuse it with the other c that I'm going to use for plus c. I could have done k. I think that the textbooks all the time put k here, k dx. And so then it would be kx plus c. You can use whatever you want. This is just saying if you have the integral of a constant, it's just going to be 2x plus c. I mean, I think everybody gets that.
Yeah.
It's just linear. Okay? All right, simple power rule. Probably your most important rule. It's the one you use the most. X to the what? Divided. So you can have x to the n plus 1 all divided by what? Or some people like to write it like this. They write the 1 over n plus 1 out front as a coefficient. I think this is kind of the way we've been doing it, but it's okay to put the whole thing over n plus 1 if you want. All right, what's the antiderivative of 1 over x? Come on, know your derivative rule in. Yes, you do need a plus c.
Ooh.
Good job. We do need plus c's on all these.
You could not be doing this right now.
I won't miss a plus c again.
No.
All right, what's this one?
Natural log after
That's when this is when you have a denominator. If you want to write a note to yourself, denominator with exponent of what? That's when you're going to use the natural log all the time. If you got a denominator with an exponent of 1, it's antiderivative. It's going to be a natural log. All right, antiderivative e dx. Antiderivative sine. Now, you can go over there and look at your derivative rules. What did we take the derivative of to get sine? You would have to use negative cosine. The c's are going to be negative. Because the derivative of cosine was negative sine, but there is no negative here, so we have to offset the negative. Derivative of cosine. Yep. Derivative of secant squared. Derivative of cosecant squared.
negative.
Yes, negative. Derivative of cosecant cotangent. Derivative of secant tangent.
Secant x plus c.
All right, these are the ones I did yesterday. I introduced it yesterday at the end of class. All right, derivative of tangent. We had to use integration by substitution for it. I did this one yesterday. Let's do it again. You don't know a function whose derivative is tangent. Look over at your derivative rules. Are there any that give you tangent when you take the derivative of them? No. So I don't know a function whose derivative is tangent, so I don't know the integral of tangent. So you have to do it with integration by substitution. You can either memorize it or on the quiz Monday, you can sit and do the integration by substitution. I'd probably memorize it for the purposes of Monday, but here's what you would do. You would make it sine over cosine, And what I do yesterday?
You did the
What did I let u be?
cosine.
I let u be the cosine. Then du would equal negative sine dx. All right, so then I did my integration by substitution. Are you ready? You missed this yesterday. Okay, Hunter. So all I'm doing is tangent. I'm just rewriting a sine over cosine so I can do integration by substitution. So I'm going to let u be the cosine, so that's going to give me a 1 over u. Is that gone?
Yes.
What do we got left to get rid of?
Negative sine.
So I need a negative du to get rid of that. That'll get rid of the sine x dx. The negative du will get rid of it. So then what I get is I get negative natural log of the absolute value of u plus c. Plug my u back in, and I'll get negative natural log of the absolute value of cosine x plus c. There is your antiderivative. Negative natural log absolute value of cosine x plus c. Now, if you can do this one, you can do the other one. You do the other one. I'm going to let you do the u substitution for the other one. Do it the exact same way, and let's see what you get. So for this one, I'm going to do what?
Let sine be u.
Yes. So you got cosine over sine. I'm going to let my u be the sine this time. So try it, and then you can look up at mine in a second if you think you have it. This one's even easier.
Oh, because it's a negative.
Yeah, there's no negative this time. There you go. There they are. Now, I have seen them do one absolutely dirty thing.
Ooh.
It's dirty.
They put a u in it.
Nope. Nope. So what? Convert what? This one right here, there's a negative out front. That's really a monkey.
They put the monkey in the tree.
They put the monkey back in the tree. What is cosine x to the negative 1 power?
Arc cosine.
Nope. I'm not taking cosine. I'm not doing inverse cosine. I'm actually taking the whole cosine x.
Secant?
Becomes secant. I have seen them be dirty before and rewrite this as natural log absolute value of secant x plus c, putting the monkey back in the tree. Now, I've seen it one time in my whole career teaching, one exam, and it was very missed, okay? And I'm going to go and tell you, 39 and 40, you're only going to see one of these on the exam if you even see it. So, for one problem, making you memorize those, and you might not even see it. Some years it's on there, some years it's not. This 41 is easy. Look at it. It's one of your derivatives.
Is it arctangent?
It's arctangent. That's the one they want you to know for the exam.
Well, why aren't the other ones important?
Arctangent's one that's used the most in trig because you use tangent pretty much for everything. Tangent's like the most popular one to use. All right, you already had this stuff. I'll write it down just for good measure. What's secant? 1 over what? Cosine x. What's cosecant? 1 over sine. What's tangent? Sine over cosine. This is for Blake. What's cotangent? Cosine over sine. You probably already got this memorized. You probably don't even need to look at mine. What's sine squared plus cosine squared? Pythagorean identities. How many Pythagorean identities are you going to do on the exam? Probably one time you'll see it. And I don't know which one it'll be. Yep. Yeah, probably, maybe twice. If you're lucky, twice. This one will be cosecant squared. And this one's secant squared. And they might rearrange it. And typically it's rearranged. It's usually not even in this form. It's usually sine squared plus cosine squared equals 1. It might be 1 minus cosine squared, and you need to know that equals sine squared. Or it's cosecant squared minus 1, and you need to know that it's cotangent squared. Or it's secant squared minus 1, and you need to know that's tangent squared. Okay? Sine 2x, cosine 2x, maybe one problem on the exam this helps you with. Sine 2x is 2 sine x, cosine x. Callie has these down. Cosine squared 2x. is there's 3 of them. If you write all 3, I'll give you extra credit. Good job, Hunter. And then you have 2 sine squared x minus 1. People ask me, how do you get the other 2? You just use the Pythagorean identity, convert the first one into the other 2. There it is. That's the 3. So if you know all 3, I'll give you extra credit. If you know one of them, you get full credit. +1 if you got all 3. Even, this just means you can drop the negative because it's symmetric to the y-axis. Odd, it's symmetric to the origin, so it's the opposite. Now, which one is even or odd? Cosine or sine?
Cosine.
Cosine's even, so drop the negative. Sine is what? Even and odd, you will for sure use it once on the exam. You always use it once. Sometimes in the multiple choice, sometimes in the free response. And it's something simple. It's like drop the negative or no to pull the negative out front. And it's usually with sine and cosine that you use it with. That's why I put them on there. All right. You should already know this stuff too. Limits. What's the 3 requirements for a limit? You guys tell me. You guys tell me. All right. This is how you have to write it on my test. You have to write limit as x approaches c of f of x exists. You can't just put exists. And you can't write limit exists. You have to write the notation. And you can use C or A. I don't care. C for constant, A for constant. You can even use K for constant. I like A.
Function value must be
And then function value f of c is defined.
defined.
And then what's the 3rd requirement? The limit as x approaches c of f of x must equal what? F of c. Average rate of change? Always do a closed interval from A to B. I usually specify that on the test, so Molly, I guess it's not exactly like my test because I usually put the A to B there. But it's just f of b minus what? What is that really? 9th grade slope, y2 minus y1 over x2 minus x1. But I want you to write f of b minus f of a over b minus a. 3 types of discontinuity. Holes, jumps, vertical asymptotes. You can put VA if you want, if you don't want to write the whole thing. Sorry. 58. What's 4 points of non-differentiability?
Discontinuity.
Discontinuity. Just go ahead and write discontinuity right away, because if it's discontinuous, it can't be differentiable. That's why continuity is so important. Then, what if it is continuous? What's 3 problems when it's continuous? Corners, cusps, and I do want you to write that one though. Vertical tangency. That's a straight up tangent line. Is that it for that page? Oh, good. This stuff rocks fast. Go to the back. Oh yeah, this is everything you need to know for the exam. Position. What's the position function? S of t. Done. That was nice. What's the velocity function? You need to write s prime of t, which equals v of t. And what do you think I'm going to make you do for acceleration? You got to write s double prime,
That is dirty.
which is v prime,
You're a dirty man.
which is what? Yep, you got to write all 3. All right, we have talked about this particle motion. It's been about a month. But it's good to review this. This is why it's good to do this. Velocity isn't velocity, just velocity. When is velocity increasing? When its slope is positive. How do you look at the slope of velocity?
You look at the line. You look at acceleration.
Acceleration. When v prime, I would rather you put when a of t, you just have to put a of t is greater than 0. You only have to put this. When acceleration's positive, that's when velocity's positive. Now, some of you are like, well, when do we got to check when they're the same sign? That's when speed is increasing or decreasing. But if you just want to know when velocity is increasing, you just got to go down 1 derivative. If you're at velocity and you want to know where velocity is increasing, go down 1 derivative. So go to acceleration. If acceleration is positive, velocity is increasing. What about if velocity is decreasing? Acceleration is less than 0. What about if velocity is constant? Acceleration is 0. Now speeding up and slowing down, that's different. And that's speed increasing, speed decreasing. So this, you have to take into consideration which direction you're going to figure out if you're actually speeding up or slowing down. So you got to know, for example, if you're running to the right and your acceleration's positive, you're getting pushed to the right, so you're actually what? The signs were what? The same. So if the signs are the same, so if you're running left and getting pushed left, if you're running left, your velocity's negative. If your acceleration, so if you're running to the left, remember, if velocity is negative, you're running to the left. The sign of velocity tells you positive. If velocity is positive, you're going to the right. If velocity is negative, you're going to the left. Now, if velocity is decreasing, which means your acceleration is negative, means you're also getting pushed left. If you're running left and getting pushed left, you're still what? So if signs are the same, you speed up. So that's what you got to remember for the AP exam. VNT, they have the same sign. What if you want speed decreasing? Different sign or opposite. You can put different or opposite. I don't care.
Opposite is more grammatically correct.
Okay, fine, opposite.
Okay, well, it's not grammatically
That's because you're
correct.
different.
Ooh,
If
well, shiesty.
it was different signs, I would agree, but it's opposite signs.
Yeah, so we'll go with opposite. Now, 67, I haven't talked about this before, but I call this common sense. I teach this on the fly. We have covered a problem doing this, but I didn't actually teach it. We just did it. If you're moving towards the origin, you have to think about which direction you're going and where you start. So first of all, if your position is positive, if you're on the right side of the origin, when would you have to move towards the origin? If your velocity is negative, so that you're moving left. So you move towards the origin when position and velocity have opposite signs.
Oh.
It's just common sense. Think about it. If your position's negative, if you're on the negative side of the origin, which way would you have to move? Positive velocity. Okay? So that's just common sense. All right, moving away from the origin. If you're on the positive side, you want your velocity to be what? So you have to have same sign. So most people just think about that with common sense. They just say, okay, I can figure that out. Speed, absolute value velocity, total distance, and then we're going to stop here and then I'll finish the rest tomorrow when everybody gets back, and then we're going to do slope fields, is the definite integral from A to B of the absolute value of v of t dt. Why do you got to take the absolute value of it? So that all your area is what?
Positive.
Positive. Because otherwise negative area wouldn't give you total distance. It would give you what? Displacement. And a lot of people like to write total distance as the sum of the displacements. Sum of the absolute value of displacements. All right. Tonight, I am going to be giving the 2017 practice exam. I'm putting it online for you to start. It's not due tomorrow. It's not due Friday. It's due Monday. So 2017 for you to start tomorrow. But I would get started because there's not a lot to do tonight. So I'd at least start looking at it.